to the fourth lesson of this week, where we're expressing remainders as a decimal or a fraction. So instead of leaving our remainders today, we've got to turn them into either a decimal or a fraction. So I'm going to go through each question, and I'm going to show you how to do a decimal and a fraction. So the first question is 93 divided by 4. I know I'm going to get a remainder because 93 is an odd number. So how many 4s going to 9 is 2, which is 1 left over. How many 4s going to 13 is 3, and that would be remainder 1. But instead of using it as a remainder, what we're going to do is we're going to use the divisor, which is 4, as the denominator, and the remainder, we said it was remainder 1, becomes the numerator. The answer would be 23 and 1 quarter. If I want to turn it into a decimal, I do exactly the same calculation. 93 divided by 4. And 9 divided by 4 is 2, with 1 left over. 13 divided by 4 is 3, and again the remainder is 1. Instead of writing it as a remainder, I'm going to put a decimal point on the top in my answer and 1 in my question, and I'm going to put a 0 in my question, and I'm going to carry the 1 forwards. So then I'm doing how many 4s going to 10? Well, I know that's 2, with 2 left over. So I'm going to put another 0. Remembering these zeros are always here, we just don't write them if we don't need them. And I'm carrying my remainder 2 over. So how many 4s going to 20 is 5. And if we know our conversions between our fractions and our decimals, we know that a quarter is the same as 0.25. So 23 and a quarter is the same as 23.25. So that's how I would solve that one as a decimal and as a fraction. Here we've got another question, 67 divided by 8. So I'm thinking this is going to be, normally we wouldn't do this in bus stop because we'd use our times table facts because we know that 67 is within the 8 times tables. But because we want a decimal or a fraction, we're going to do it as short division. So how many 8s going to 6? We know is 0, carry the 6 over. How many 8s going to 67? We know is 8 with 3 left over. So again, instead of writing the remainder 3, if I want to turn it into a fraction, I put my divisor, my 8, as the denominator, and the remainder becomes the numerator. So it's 8 and 3/8, or if I wanted to write it as a decimal, I do my calculation again. How many 8s going to 6? We know 0 with 6 left over. How many 8s going to 67? We know is 8 with 3 left over. So again, like here, we're going to put the decimal at the top in the answer and in the question. We're going to put the 0, and we're carrying the 3 over. How many 8s are in 30? We know is 3, which is 24, which leaves us with 6 left over. So we're going to add another 0 and put the remainder here. So we're now thinking how many 8s are in 60. So we've got 8, 16, 24, 32, 40, 48, 56. So it's going to be 7 8s are in 60 with 4 left over. And we're putting another 0 and we're carrying the remainder over. How many 8s are in 40? I know is 5. Now I know that 3/8 is the same as 0.375. So 8 and 3/8 is the same as 8.375. And that's how I would calculate that one within my remainder as a fraction and as a decimal. Here I've got another one. Again, this is normally within our times table facts, so we wouldn't do this in short multiplication unless we wanted a decimal or a fraction remainder. So how many 6s are in 6? We know is 1 with nothing left over. How many 6s going to 14? We know is 0 with 4 left over. So if I was making it into a fraction, my divisor, my 6 becomes my denominator, the 4 left over and the 4 remaining become my numerator. And then we can do it over here into a decimal. So we've got 64 divided by 6. Again, we've got 1 6 in 6, none in 4. We need to put a decimal point on the answer and 1 in the question. And the zeros that we know are always there as place value holders, we just don't always see. So then I'm carrying over my 4 to make it 40. How many 6s are in 40? We know is 6, which is 6 times 6 is 36. And there are 4 left over. And we know that 6 goes into 40 6 times. 6 times 6 is 36, with 4 left over. And this is one of these questions that would carry on going forever. So what we do is we put this little symbol up here, which means reoccurring. The answer is 10.66666 reoccurring. Now, Some of you will know that 4/6 is the same as 2/3, which is 0.6666 reoccurring. So I know that these two numbers are the same. 10.66 reoccurring is the same as 10 and 4/6, or 10 and 2/3. Some of the questions look like this. You've got a missing box, divided by 9 equals 11 and 2/9. So we've got to use that inverse. We've got to be timesing these two numbers to get our big number that goes here. So I would do that in 2 steps. 9 times 11 equals 99. 9 times 2/9 equals 9 times 2 is 18. And the 9th at the bottom doesn't change because the pieces of my fraction are changing size. And 18/9 is the same as 2. Because 9 times 2 is 18 and 18 is my numerator. So the answer here would be 99 plus 2, which is 101. Now these questions are quite tricky in Challenge C, so you might want to have a go at Challenges A or B before you start Challenge C on the PowerPoint. And good luck, and I will see you tomorrow for the last video of the week.